Hello everyone and welcome to this video on creating computer-aided manufacturing programs in Autodesk Fusion 360. If you would like to follow along with this example, you can find the F3D file in the video description below. Okay, I'm going to be moving fairly quickly through a lot of this example. If you would like a more detailed description of some of the things that I'm doing, please look at the video titled CAM Example 1, where I explain a lot more of these operations in much more detail. Okay, so upon opening up this example, hopefully we can see that we're going to be machining this spar component in the center here, and that this spar component will be located between two vice jaws which are represented by these bodies below the model. By default we will be in the design workspace, so the first thing we need to do is we need to move to the manufacture workspace. And as always when we're creating CAM programs, the first thing we need to do here is create a setup. So I click the setup button on the top left. We're going to be doing a milling operation, so this is correct. I'm just going to check the orientation and location of my work coordinate system. I can see that I've got the Z-axis set correctly, and that work coordinate system is in the center face, or the center of the top face of my stock, which is exactly where I want it, so I don't need to change any of the options here. In this particular example, we have got models for both the component that we are machining and the fixtures, so I need to tell Fusion 360 which is which. So in the model section, if I click the arrow here and then pick the model or the component which I'm actually creating a CAM program for, I then want to enable the fixture option, and I want to select the two bodies or components which represent my fixture. Once I've done this, I can move across to the stock tab, and if I change to the right hand view, I can see that this particular design has been set up in a very certain way, and what that is that the stock should be seating or should allow the component to seat within the vice jaws here. So I want the stock to seat right in the corner here and locate itself, and the way that I can do that is by manipulating the size of this stock. So if I increase the side offset and I increase the bottom offset, we can see that we can get that stock to rest exactly in the corner of those vice jaws, which is where we need it to be. We're not going to be doing any post-processing here, so I can press OK, and that will complete our setup. Now, at present, we have the work coordinate system in the center of the top face of the stock. So to make sure that we have that set correctly within the machine, the first thing we're going to do is we're going to do a probing operation. So if I go to the setup group and I go to probe work coordinate system, very similar to how we set up toolpaths, we're going to work top to bottom, left to right. So I'm going to go and find my tool. Now, there aren't actually any probes in the tutorial metric library, which is what we usually use for these examples. So I'm going to go to sample probes about halfway up. And because we're only probing the external of the stock, it doesn't really matter too much what the size of probe that we use is. I'm just going to use a 5mm probe here and press OK. We also need to set a lead-in feed rate. This is mainly to make sure that we're not approaching the model too quickly. We're going to set this to something sensible like 5mm a minute. I'm then going to move across to the geometry tab. Now by default, Fusion 360 will assume that we're trying to probe the model, i.e. we want to check an item that we have machined. This is not correct. We want to probe the stock, and we want to make sure that we've got that stock work coordinate system set properly within our machine, and we want to probe this top surface here, so we just click that and we can see immediately that Fusion 360 has created a toolpath where the probe is going to tap on the top of the stock and then each side of the stock as well to locate that work coordinate system. I'm happy with that, so I can press OK. If I just do a quick simulation, so I go to the simulate button, normally by default the stock won't be shown, so we need to enable the stock, enable the toolpaths, and let's just press play and see what that probing operation is going to do. So it's going to touch on the top of the stock, each of the sides, and from those measurements it's going to calculate and tell the CNC machine exactly where that work coordinate system is. Excellent. So I'm happy with that, so I can close the simulation and I can start creating my toolpaths. So the first toolpath that I'm going to create is a face milling operation. So I go to the 2D group and face. I need to pick my face mill. So I'm going to go into my tutorial metric library and pick the only face mill to which I have access, which is the 50mm face mill. I'm happy with the speeds and feeds that have been imported from the library. I'm happy with the default geometry selection. I just need to check the heights. So we're going to start machining at the top of the stock, and we're going to stop machining at the top of the model. That's correct. So I can press OK here. If I just do a quick simulation, got the probing operation followed by my facing operation. That looks good, so I can close the simulation tool. So the next thing I'm going to do is I'm going to do my roughing operations. So my roughing operations will remove material from each of these pockets as well as from the outside of the model. I'm then going to look at my finishing operations. So for my roughing, I'm going to use a 2D adaptive toolpath. So I go to 2D adaptive clearing. Now actually, in order to select the tool, I just need to do a quick measurement. So let's use our inspect tool and see what some of these radii are. So we have 5mm, 5mm radius, 5mm radius here. So because all of these internal radii are 5mm, I think I want to be using a 10mm diameter cutter. So I go back to 2D adaptive clearing. In my tool, I'm going to select a 10mm bullnose cutter. This is because we're doing a clearing operation here. We're not bothered too much about creating the exact geometry just yet. And this little radius on the edge of the bullnose helps the tool to resist wear a little bit more. So we're going to use that tool there. Let's go across the geometry tab. So for the first adaptive clearing operation, I will do this pocket and this pocket. Now it's worth noting here that Fusion 360 will allow you to select as many pockets or geometries as you want, but you only have one heights tab. So we could have picked this pocket in the center, for example, but we would need to machine to the same height in all three pockets. So because this pocket is a different height, actually I'm going to pick this in a different operation. So let's go to our heights tab. So we want to start machining at the top of the model, because we've already removed that little bit of stock on the top of our model during our face milling operation, so we don't need to start machining that high. And the bottom height, I want to go to selection and pick the bottom of those pockets. I'm happy with that, so I can press OK, and let's just do a quick simulate on that setup just to see what we've got here. So we've got the probe, face milling operation. I've got the 2D adaptive clearing operation, which is clearing out the majority of the material from the inside of those pockets. I'm happy with that, so I'm going to create some more adaptive clearing operations to remove the material from the center pocket and from the outside. So if we close the simulation, I'm going to go to 2D adaptive clearing. I'm going to leave the same tool selected. I'm going to pick this pocket here, heights. I'm going to machine it from the top of the model, and I'm going to machine down to the bottom of this pocket and press OK. That toolpath looks good. And then I'm going to create another 2D adaptive clearing operation with the same tool. This time I'm going to machine or remove material from the outside of the component. I can see that Fusion has shaded the area where it's going to remove material, so I can tell that that's removing material from the correct side of that contour. The heights I want to machine from the top of the model, and this time I want to machine it to the bottom of the model. I'm happy with that, so I can press OK. And now let's have a look at our whole setup and see where we are. So I've got the probe, the face milling, the first 2D adaptive clearing operation, and then the 2D adaptive clearing operations for the center pocket and for the outside. Excellent, I'm happy with that, so I can move on to some of the finishing operations. So I'm going to close this. Now to finish the pockets, I'm going to do a 2D contour. Actually, I'm going to change the tool here, and I'm going to change this to a 10mm flat end mill. For the heights, I want to start machining at the top of the model, and I want to stop machining at the bottom of these pockets. And I'm going to do exactly the same thing for the center pocket. And I'm going to do exactly the same for the outside of my component. So I'm just going to simulate all of that now and just see where we are. So we've got the 2D adaptive clearing operations that we've already seen. Excellent. So I can see that I've cleaned up both the inside of the pocket faces and the outside of the component. I may choose to come back at the end of the program and do this in multiple heights, so go once round at maybe halfway around the halfway down the part, and then one at the full height. But we can tweak these sorts of things at the end. I can see that I've got some material left in the bottom of the pockets here, so I'm going to fix that now. So let's close this. So to get rid of this material in the center, I'm going to use a 2D pocket operation. I'm going to stick with my 10mm flat end mill. I'm going to pick the pockets here. For the heights, I want to stop machining at the bottom of these pockets, but then actually, because I've already removed the bulk of the material, I don't want to start machining at the top of the stock, because then I would be spiraling in to my component and machining in fresh air for an awful long time before I get anywhere near to the material that I need to remove. So actually I'm going to set this to the same selection here at the bottom, but I'm just going to move this up by 2mm. I'm going to press OK there, and I can see now my tool spirals a few times, and then it removes the material in the bottom there. I'm just going to edit that that pocket operation again. I'm going to check my passes tab, and actually this is defaulted to leaving stock, so I don't want to leave stock on that particular operation. So I can press OK there. And I'm now going to set up exactly the same finishing operation for this pocket here. And then again, I will simulate the whole setup just to see where we are. Excellent. So I can see I've completed the pockets on the inside. I've completed the outside of my component. All that I have to do now is the holes in the corners of the component and the chamfers. So I'm going to do the chamfers first. So if I close this, now to do a chamfer, we're going to use the 2D contour operation. We're going to pick the chamfer tool. So we go to tutorial metric, and there is only one chamfer mill. So we pick this. On the geometry, I'm going to pick the bottom edge of the chamfer, and I'm going to do this for all of the chamfers that I need to create, and then press OK. Again, let's just do a quick simulation and see what the resultant looks like. So if I now turn off the visualization of my toolpaths, and I turn off my models as well, I can see just what the result of the simulation will show me. I can see we've created these chamfers, and these all look green, which means my geometry looks good. Okay, so if I close that now and turn my models back on, the next thing that I need to do is I need to make the holes in the corner of my component. So for this, I'm going to be using the drilling operation. So if I go to my measure tool and I measure this hole, I can see this is 4.234 millimeters. It's kind of hard to figure out exactly what this hole is. I can see by the texture that this is a tapped hole. Often the best way to check what this hole actually is to go back to the design workspace, find the hole feature, which I can see here, edit this, and I can see that this is a M5 by 0.8 hole. So I can OK that, and I can go back into the manufacturer workspace, and I now know that I'm making an M5 by 0.8mm threaded hole. What's actually happened here is that I've got these red warning icons next to all of my toolpaths. All that this means is that Fusion 360 thinks that I've edited some of my geometry, and now it can't, or it needs to regenerate all of the toolpaths again. It needs to recalculate what they are. So if you just shift select, or if I just shift select all of them, right click, and then click the generate option, it will go through one by one and it will regenerate all of those toolpaths, and we can see it's it's already got through all the way through half of them at the minute, and that's now complete. Okay, so for my drilling operation, if I go to drill, I'm going to select my tool. So the first thing I need to do is I need to drill the hole in the center. So if I go to tutorial metric, and I needed a correct drill, so I know I'm drilling, or I'm creating an M5 hole. So probably the closest drill to the proper tapping diameter that I have is 4.3. So if I press OK here, go to geometry, again I'm going to select my hole faces, I'm going to select all of the same diameter, and I'm going to press OK. So what that's going to do is that's going to remove the material from my hole. The next thing I need to do is I need to tap each of these holes. So I'm going to do that using a tapping cycle. Again, we go to the drill tool for the tool. Again, inside the tutorial metric library, we're going to find a tap. So I've got an M5 by 1mm tap right hand. Now that's not quite the 0.8mm specified in the model. So at this point we would need to talk to the designer, and we would need to say either we need to change that particular thread, or we need to order in some more tooling so that we've got access to an M5 by 0.8mm tap. For the purposes of this example, we're just going to use this M5 by 1mm tap here and press OK. And we're going to do exactly the same as we did for the drilling operation. So I go across to geometry, I select the faces, I select the option to auto select same diameter, and the only thing I need to check here is on the cycles option. So in cycle I've got tapping here. It is very important that this is enabled for any tapping cycles. This is because when we create a tap, we need to ensure that the rotation of that tapping tool is synchronized with how the tool is moved in the Z height, and that's to cut the appropriate corkscrew thread. If this is not done properly, we'll just try and drill with a tap, and that will smash both our tool and our workpiece to bits. So we don't want to do that. So we've got this selected as tap. That's fine, so we can press OK. And that's all been created. So let's just do it again, do another simulate, and just see what that results in. Okay, now I can see that for some reason I can see my model through these holes that I've created here. One thing we need to check is that we're not masking any areas where we've removed too much material by enabling visualization of the model. So if I hide the model here, I can see actually these holes are far too big. So I need to investigate why that's happening right now. What I would suspect is that the geometry used for the simulation is the external surface of this tapping tool here, and that's actually bigger than the diameter which is in the 3D CAD model. So I just need to make sure that this is a visual artifact and not me creating the wrong geometry. So if I close that here, just double check that tap operation. So I can see we're using a diameter 5 tap there. And again, I'm going to go back into my design and I'm going to double check. And yeah, I can see this is an M5 hole here. So I'm happy that that's a visual artifact and not something actually wrong with my CAM program. So if I go back to the manufacturer workspace, the last thing I need to do is I need to just create these countersinks here. Again, I can do this with a drilling operation. This time the tool that I want is the countersink tool, and I can press OK. If I go to the geometry, again I can just pick the actual countersink faces. I can auto select the same diameter and press OK. And I'm just going to simulate that last tool path and just check that that's looking okay. And I can see that that's creating the correct countersink. And now I can simulate the whole setup. And I can see, with the exception of the visual artifacts in the corner, that all looks correct. Now obviously, to finish off this component, I would need to do some milling on the other side of the component. So I would need to turn this over in the vice jaws and complete some more milling operations. The way that in which we would accomplish this in Fusion is by creating another setup in a different orientation and using a different fixture geometry. We're not going to cover that just here. So for the purposes of this video, we've finished with that example. Okay, thank you very much for your time, and I'll see you in the next video.